We have just 2 units left. Yay! Unit 10 is all about circles. And before we can really get into lesson 1, which is about arcs and arc length, we need to talk about some circle basics. Because guys, I don't really think that we've done anything with circles this whole school year. So here we go. Naming is important in geometry. To name a circle, you name it by its center point. So this would be just circle O. Nothing crazy yet. Radius and diameter, you've heard those words before. Let me remind you what they are if you forget. A radius is a segment from the center of the circle to the circle, which kind of sounds strange, but it just goes from the center to the circle. So like OB, that would be an example of a radius on this top picture here. I feel like we know that. OC, OD, OE, all of those are radii. A diameter is just double that. So it's a radius times 2. It's got to go through the center as well. So like maybe you start at E, go through the center O, all the way to the other side of the circle. So EB would be an example here, or AC. Same difference. So we'll say EB, that segment would be a diameter. Circumference, you probably haven't heard that word in like several years, but the circumference of a circle is the distance all the way around. Think perimeter. I'm going to make that note here. We have talked a lot about like perimeters of shapes, other shapes. They call it something fancy for a circle. They can't just say perimeter of a circle. I don't know why, but they call it the circumference. So that's just like if you took the circle and like made it into a line, spread it out, and actually measured it with a ruler all the way around, that's your circumference. There's a formula for that, and it is 2 pi r. Things coming back to haunt you. We will not use 3.14 for pi in our class. I think they tell you that in middle school because your calculators didn't have a pi button on them. Ours have a pi button, so we are better than that now. Just a little heads up. Okay, there's some basics. Now let's jump into what lesson 1's all about. It's all about arcs. And before we can like find different things in relation to arcs, we need to talk about what is an arc. So an arc is just a portion of the circle around the outside. We just mentioned what perimeter or circumference of a circle is. So just a portion of the outside of the circle. Those pieces are called arcs. There's 3 types of arcs, and we've listed them here on your notes. The first is a semicircle, which you probably would know what this is. It's an arc that's exactly half the circle. Then there's minor arcs and major arcs. So minor arcs are arcs that are less than a semicircle or less than half a circle. And major arcs are more than a semicircle or more than half. So guys, I'm just thinking like, okay, that little piece, that little piece. This is half of a circle. So that's your arc. That's your semicircle that they're talking about. Just around the outside. Now, naming, here we go again. How you name arcs is important. To name a minor arc, you use just 2 letters, like kind of where you started, where you stopped. To name a semicircle or a major arc, we're going to use 3 letters. It's the start and stop, and then that middle letter kind of tells you like which direction to go to connect them. That's kind of how I think of it. There's like 2 pieces here. So that's what an arc is. There's 2 pieces to today. Finding the measure of an arc and finding the length of an arc. And they kind of sound similar. We're going to talk measures first. So let me go here and add a note really quick. Measure means degrees. So if you're thinking how many degrees is a circle, you probably know this. It's 360. Maybe make that note. There's 360 degrees all the way around a circle. So like the full arc going on here, the full circle, 360. If I'm talking half a circle, that's 180. 360 divided by 2. If I'm talking less than half a circle, that's an arc that's got to be between 0 and 180. And then major arcs more than a semicircle have to be between 180 and 360. Okay, just thinking out loud here before we really get into what's the measure of this arc, which is where we are now. So the measure of an arc is determined by the arc's corresponding central angle. Throwing so much at you, but your arc is going to go with an angle at the center of the circle. And whatever degrees that is, that's how many degrees your arc covers in the circle. So they go together, it kind of makes it easy. So for example, if I come back to this picture and they're saying, look at arc BC and see how they did little arc symbol above the letters. That's how we'll note that that's an arc, not a segment. Arc BC, so let's use my green here. That's this guy right here. That's what they're talking about when they say arc BC. That's made by two radii, this one and this one. Kind of makes a little pie piece. So OB and OC kind of help form the start and the stop point of this arc. Put that in there. So guys, the central angle that goes with BC, and you can probably see it, it's just this little pie piece right here. So this is a central angle at the center at O. That's 57 degrees. That corresponds with arc BC, which is also going to be 57 degrees. And it makes sense, there's 360 around here, 360 around the outside, whatever this central angle is, the arc is the same degrees. Okay, so in this case, it goes with angle, we'll call that BOC, which is 57. So that arc is the same thing, like we said. Note here, because you'll see them ask this, what's the M of arc BC? That just means what's the measure, which again, that's just how many degrees does it cover out of the 360. That's all that means. If I'm thinking how do I classify it? Which one of those names would I call this arc? Well, it's between 0 and 180. It's less than half of a circle, BC, so it's a minor arc. And I kind of already knew that from the beginning because they used two letters to name it, so just saying. Woo, okay, let's just practice naming some arcs here. So I'm gonna name the first two, and then you can name the last one. Or the first one, you name the last one. How about we try naming 3 other minor arcs besides BC? So many options, guys. Anything that's less than half a circle, use 2 letters. So maybe I'll say DE. You can't see that. DE, ED, same difference. Put the little arc symbol above it. Maybe I'll say BA. That's less than half a circle. Why don't you try doing one more? Note it in your notes what the answer is. What about semicircles? Well, you'd want to look for a diameter that separates the circle in half. So there it was. So here's a semicircle, here's a semicircle. We just have to name them. 3 letters. So the start and the stop point, I'll name the top one, you're going to name the bottom one. Start and stop point would be the ends. The middle letter is just one of those letters, one of those points between them. So I could call this BCE. I could call it BDE. I could call it EDB. Tons of options. I'm going to call it BCE. See if you can name this bottom semicircle. Make sure you note it on your notes here. And then we'll do 3 major arcs. So again, this is so inconvenient. I have to go up and down here, but I'm going to name 2 major arcs. You pick the last one. 3 letters, anything over half. So maybe I'll start with B and I'm going to go to the left. So I'm going to say BCA. BCA. That would be over half. And then maybe I'll do A. Let's go no, let's not do that. Let's start with E. Let's do ED, EDA. That's another one. Be careful not to name the same arc there. Sorry, don't know if you saw that. That can be easy to do, accidentally like repeat, just like going the other way, but make sure it's a totally different arc. Mark it there. Okay, on the back, here's another practice example with measures. So circle Q, that's what that means, the circle Q, that's the name here. I want to find the value of X. It's going to save your life on a lot of examples to look for diameters, guys, because that separates your circle into 180 and 180. So see that diameter there? I know that this is 180, this is 180. That is going to be so helpful. And look here, X is used in these central angles, these angles in the middle. Think about these three together. They make that line, that diameter. And I know there's 180 in a line. So if there's 180 down here, 180 up here, however I slice it, those three angles should add together to be 180. I feel very confident in your algebra skills, so solve that. X equals 19. Now I can plug that in to find the measure, how many degrees these different arcs are. So check it out. NP is right here. That goes with this central angle right here. So I'm just going to plug in 19 into my 4x plus 1, and that's going to give me my degrees for my arc, because those are the same. It's 77. LK is over here. That goes with this central angle. I don't know if you guys can see this, but like there's a big X. These guys are vertical angles. So that central angle would be 77. LK would be 77. PK, another minor arc. Where is it? This is P, is right here. Ooh, here's where the 180 is going to help. This whole thing is 180, and I just found out that that was 77. So 180 minus 77, that would give me PK, which is 103. See if you can find how many degrees LMK is. That is a major arc, so be careful when you connect those. LMK. It's almost the entire circle, not quite. Okay, so that's measures of arcs. Finding the length of the arc is like, okay, if I'm actually going to take this arc and I'm going to stretch it out into a line and measure it with my ruler, that's how long it is, like 2.5 inches. It's not degrees that I'm talking about anymore. Measure and length are different. Realize that. Now, arc length is a fraction of the circumference. Circumference, we said, was just like the perimeter all the way around. This is a fraction of that. It's just a piece of that. So there's kind of like a formula. I don't know. It's a formula, but it's more of a concept. You basically are going to find the measure of the arc, how many degrees it covers, out of the 360. That's how you get your fraction. You're going to multiply that by your circumference, which is 2 pi r. So watch. If I'm looking at this example, here's arc AB. It's a minor arc. It's 2 letters, so I'm going to connect it so it's less than half. I want to find the measure first. How many degrees? The central angle that it goes with is 45, so that arc is also 45 degrees. That's how many degrees of the 360 it covers. I want to figure out, well, how long is that arc if I actually measured it? So here's what I do. I'm going to think big. I know that all the way around is the circumference. So let's find that. 2 pi, the radius here is 12. Okay, notice they say leave it in terms of pi. It's the same deal as like simplest radical. You don't multiply the pi in your calculator. So I would just do 2 times 12 and then stick the pi back on. So 24 pi is like the distance all the way around. That's too big. I just want a fraction of that. I want the fraction that this arc covers. So I take its measure and divide it by 360. This arc covers 45 degrees out of the 360. Carry that down. I want a fraction of the circumference. Here's how I'm going to multiply that in my calculator. Leave the pi out. Okay, do 45 over 360 times 24. It's just 3. Then stick the pi back on. So it covers 3 pi, whatever the units are. All right, see if you can do the next one. BCA is this arc right here. major arc.